Hello, everyone. I hope you all are doing amazing. Welcome to the last lesson, the lesson 10 in the chapter 3. This is about the mean value theorem. This would be the last lesson, even in your end of term exam, because the exam scheme has already been released, and I'm sure you all might have gone through it. And a quick clarification about the EOT videos. I will definitely do the EOT videos, but it's just that I'm doing the presentations and I was busy with many things. I will try to do them very soon. In just a few days, I'll start uploading questions as I complete them. Please do stay tuned. And this is the last lesson explanation. And after this, the next video onwards would be the EOT explanation videos for the cycle 3, that is 9, 10, 11, and 12. So now we will begin this lesson. The objectives is mainly there are two objectives, that's about Rolle's theorem and the mean value theorem. The keywords would be the Rolle's theorem, the mean value theorem. So we will look into the Rolle's theorem first. This is not there for your term exam, but still this is important because after this, mean value theorem can be said like a modification of the from this. Okay. So what is Rolle's theorem? There are few important points in this. Rolle's theorem. Suppose that f is continuous on an interval, say interval AB, a closed interval AB, and differentiable on the interval AB. This is also important on the same interval, but it's open interval. And f of A equals f of B. Then there is a number C which belongs within this range AB such that the derivative within that range is 0. Now, what it means is there are three conditions. The first condition is this one, condition 1, continuous. Sorry, that was very bad. Okay, now the first one is about continuity. Okay, next one is about differentiable. And then this three conditions are to be met. Now, if you just see the equation, if it passes these three conditions, then and only then you can tell there is a number C such that it will belong to within this limit and its derivative at that particular value will be 0. That means this is the point, the derivative is equal to 0. So it will be a flat line basically. So say like this, okay? Derivative is the slope of the tangent line, isn't it? So that is 0. Let's see a figure over here. Now, if these three conditions are met, then only then, see, this third condition is also important. A function of A and function of B must be equal. Then somewhere we can see there will be a turning point. It really makes sense. If you analyze it properly, then you can realize if there are if it's a continuous, that means what is continuity? Continuous would mean anything that is not having any holes or no discontinuity. So there should not be any holes, or it should not be a jump discontinuity, something like this. The point is over here and this, or a asymptote. These must not be there. It must be a continuous function. And what is differentiable? Differentiable in the sense there must not be any, like this, sharp turns or cusps, all that. Okay. So this is about differentiability and continuity. Say, for example, we had studied which is differentiable at every time. For example, a polynomial function x squared plus 2x. This is differentiable all the time, everywhere, all interval from minus infinity to infinity. So the thing is, they will give an interval. We need to check these two, and then whatever the function is given, you need to substitute these two intervals over here and then get it. We will solve the problem, you'll understand much easy. But what I wanted to emphasize is, if it is continuous, if it is differentiable, and if f of A and f of B is equal, then obviously if it's not a flat line, it will be something curved like this. See? If it is going up, then it has to come down. So that means there will be a turning point, isn't it? It must be 0. The derivative must be 0 within that range, no matter what. So if you analyze it properly in a graph, then this pretty much makes sense. Why? Because there is a point over here and over here which is equal. The y value is equal. F of A and f of B equal means the y value is equal. Okay. And It is continuous and differentiable. So whether it is going up or down doesn't matter. See over here, up or down. There will be a point where the differentiation of the function is equal to zero. That means there will be a tangent line which is flat. The slope is zero over there. Okay, now we will just quickly move on to a problem and see it. Say, for example, this problem. We need to find the value of c that satisfies the conclusion for Rolle theorem for this given equation. Here, look at the given function f of x. The intervals are 0 and 1. This is also important. But now let's look at this one. This is a polynomial. Doesn't matter what, it's continuous everywhere and it is also differentiable everywhere. So there is no problem in such questions at all. So you can understand this is continuous and differentiable everywhere. So all you need to do right now is find f of a that must be equal to f of b. Okay, what is a value? This is a, this is b. So what you do is just over here, instead of x, you put the a value. So I will put over here f of 0 must be equal to f of 1. And now this must be now 0, x must be 0. So let me substitute. It should be 0 cube minus 3 into 0 square plus 2 into 0 plus 2. That must be equal to 1 cube minus 3 times 1 square plus 2 times 1 plus 2. Let's solve this. 0, it's 0 here, 0 here, only 2 remains. Now what about this? It's going to be 1 minus 3 plus 2 plus 2. So it is going to be 5 minus 3, that will be 2. Because for 2, 4, 5 minus 3 is 2. Yes, the first condition is continuity. Continuous. Yes, it's continuous. Second condition is differentiable. Differentiable. See, now it should not be differentiable every way. It should just be differentiable at 0 and 1. Yes, it is, but this polynomial function is differentiable everywhere. So there is no problem at all. Now the third one over here is f of a equals f of b. Is that met? All the three conditions are met. Now we can use Rolle's theorem. What does Rolle's theorem say? It says that the derivative at a particular point must be equal to c. This we don't know what is that point, so instead of x we will take c. Even you can take x, it's fine. Just derive this. Find the derivative of x. But now since over here that Rolle's theorem, it's only when it applies, so we can just one second, instead of x I will take f of c. Okay, it'll be c cube minus 3c squared plus 2c plus 2. And then the derivative of this would be, derivative of c would be 3 comes down c power 2. Why power rule? 3 comes down c power 2 minus 2 is multiplied with 3, it will be 6c power 1 and plus 2. This is 0 derivative of this. So now whatever is this, what is that? Let me write over here. It is 3c square minus 6c plus 2 will be equal to 0. Now how do you solve this? You can use factorizing method, or I'll just use the calculator directly and solve it here. You can use mod phi 3, and now just input the values 3 minus 6 and 2. Now the values are, sorry, let me just go back. X1 is 3 plus 2, 3, that's 1.57 and 1.58, and there is one more value which is 0.42. Now here we got two values. Let me just write them down. The C values correspond to 1.58 and 0.42. Are they both in this interval? This is not in the interval, so this is not required. But whereas this value, yes, is in the interval, so this is the C value. Now, if you graph it out, if you graph this equation out, at this particular value, say if you graph this, it's a cubic function, it will be something that's positive, just something like this, okay? Okay, now that is not a right graph, but anyways, at this particular point, at this 0.42, you can see the derivative would be 0. That is what it means. So this is the thing. That is why Rolle's theorem is useful. Let's just see there is no graph over here. I just now clipped it from Desmos and brought the graph here. If you just put this in Desmos, you will get a graph. Now, here you can see these the two values we got were 1.577 and 0.42 something. And you can see there, if you draw a tangent line, like the derivative is equal to means the tangent line would be 0. It is a turning point. You can see that. That is what we have found from Rolle's theorem. But here in this particular problem, the interval what we require is just 0 and 1. So just stop it over there. Like just choose whichever is within the value. This was the value, right? So 0.422. It'll be 226. So it's 0.423. Okay, that is the correct answer. I hope this is clear. This is about Rolle's theorem, how we can find, and you can see, you can easily compare the answer as well. Now here about mean value theorem. Mean value theorem is similar to Rolle's theorem. The first few parts are exactly same. What did we see in the previous one? Continuous. Yes, it must be continuous. That's the first point. Second, it must be differentiable. Within that interval, it must be differentiable. Whenever it is continuous, it's a closed interval, whereas differentiability is the open interval. Why? Because we need to check from both these sides, isn't it? And therefore we cannot assure this particular point is differentiable. Anyways, now here then there exists a number c such that the derivative of f dash of c is equal to the function with this to limit. What happens is your now look carefully over here. What is this formula exactly? It's a slope formula. It's like y2 minus y1 by x2 minus x1. Now here if you go in detail, you can understand that f dash of c means what? That is the slope of the tangent line, isn't it? That's the slope of the tangent line. This is equal to, if there are 2 points, can it be tangent? No. Tangent means only one particular point, exactly 1 point. If there are 2 points, then it's a secant line. It touches 2 points. So this right side, there are 2 points, right, interval points. It's a secant line. Basically, you're finding the slope of the tangent line and the slope of the secant line. This is about tangent, this is about secant. We will do a problem you'll understand much better. Let's see this one. Find a value of c satisfying the conclusion of the mean value theorem for f of x equals x cubed minus x squared minus x plus 1 at this interval. Now, since you have been given a polynomial function, this is a cubic function, that means it's a polynomial function, right? It's so easy when there are x cube, like I mean like a polynomial function. Whereas if it's a square root function, then we need to know the graph of this. If it is a rational function, we need to know the graph. Okay, so this is very important. Now here, since it is a polynomial function, we know it is continuous everywhere and differentiable everywhere. So no problem at all over here. All we do over here is find, okay, now this is it. For the mean value theorem, it's just the two conditions. Let me just quickly go back and let me just check. Yes, see only the two conditions need to be met. And now we just use the formula. I mean, we just use the formula of the mean value theorem. Let me just use it. Let me write it out over here. It is f dash of c that is equal to f dash of, sorry, not dash over here, f of b minus f of a divided by b minus a. Now, all the value that's required is given in the question. Yeah, I'll just remove this. Let's find the left-hand side now. Let me do the derivative. We can take this as f of c. That will be c cube minus, again, c square minus c plus 1. You can even take it as x if c is confusing. You can take it as any number, say y or anything. Don't take y and x, sorry. Take it as a, b, a is a and b is gone. So that's why next number would be C, but you can take L, M, N, O, P, Q, anything, okay? Whichever is comfortable. Now, next one would be derivative of this. That is 3c squared minus 2c minus 1. This is 0. Now, what do? You need to, you don't substitute over here 0 or anything, just write it over here. It is 3c squared minus 2c minus 1. That is equal to, now we have f of b. This is a, this is b. That means this is basically f of 2 minus f of 0 divided by 2 minus 0. Now what is f of 2? That is equal to, instead of x we have to put 2 cube minus 2 square minus 2 plus 1. This would be 8 minus 4 minus 2 plus 1. It would be minus 6. 2 plus 1 is 3. This is 3. What about f of 1, f of 0? It'll always be very easy if it's 0. It's 0 cube minus 0 square minus 0 plus 1. So you're remaining with 1. Now substitute over here. 3c square minus 2c minus 1 equals, what is f of 2? 3 minus 1 divided by 2 minus 0 is 2. So this would basically turn to 2 by 2 is 1. And now take this 1 to the other side. It will be 3c squared minus 2c minus 1 equals 0. This can be also written as 3c squared minus 2c plus, sorry, what happened to me just now? It's minus 2 is equal to 0. Now you can take out your calculator and solve that quadratic equation. Here you just press more 5 and 3. And now let's see. 3 equals minus 2 equals minus 2. What are the values? It's 1 plus 7 root 7 3. That is 1.21. Let me just write it out over here. C is equal to 1.22. I just approximated it. And the other value is minus C and minus 0.55. Now these are the two values we got. Now, can we choose this negative value? No, because it's out of the limit. So the final answer would be 1.22. So here you can see 1.22 is considered, right? Let me just remove everything. This is detailed way to write it out and solve it. And this would be the final answer. Now, what does that answer mean? What does it signify? Let's see the graph here. We know the left side derivative of c means the tangent line. This is the tangent line. The right side at 2 and 0, f of 0 and at 2, that is the secant line. Can you see? Now since both the slopes are equal, we are equating. Can you see they're parallel to each other basically? This is the thing. Now over here this line is parallel to this line. Basically we find a point where they are exactly parallel to each other. Okay, so now this is the thing. From this point to this point, that is equal to this. And where is it exactly? At 1.33 or something. At this value, we saw it in the calculator was something 1 point something over here. So this is the point. So that is basically it. If you draw a straight line, you can see that they are equally spaced. So that is the mean value theorem. And that's basically it. This is very important concept. Now one important thing to remember is you need to find whether it's continuous. See, all polynomial functions are continuous, so there is no problem at all. You need to find see whether it's differentiable, not at everywhere, just at this particular point. Yes, this is. And then you can use the mean value theorem. For Rolle's theorem, we have to also find f of a and f of b, which is not there in this. We directly apply this and we find. And we are not telling the derivative is equal to 0 or something. No, we are just telling the derivative of the tangent line and, sorry, the derivative of the function is equal to the slope of the tangent line. That's it. And I hope it is clear. Please do practice more problems on yourselves, by yourselves in writing, because this topic is there for writing in your term 1 end of term exam. All the best. Do practice more problems, and I will try to do the EOT videos as soon as possible. If you have not yet subscribed to my channel, please do subscribe. It would mean so much to me. Happy learning and see you soon. Bye bye.